So lesson P1, we're going to start back in the basics, the same places you started in algebras and even some of the middle school, but numbers. What does it mean? Let's start with what does it mean to be a real number? Thoughts? I know it's just kind of... Huh?
Any number above 0.
So negatives aren't real?
No.
I disagree there.
Real numbers are any whole numbers.
So decimals aren't real? Fractions aren't real?
All numbers are real.
Except?
We know what
Zero.
Imaginary.
Ooh, except imaginary?
Like I.
Remember I?
Yeah.
We
And like
learned that
eight.
last year. Okay, so we talked about an imaginary number last year, but real numbers are pretty much everything we deal with, right? The fractions, the decimals, the positives, the negatives, the whole numbers, okay? What I have written in here, any number that can be written as a decimal, okay, and not imaginary. So you can kind of write in what you want. Should have written this in ahead of time, but any number that can be written as a decimal. You could throw in not imaginary. And as we go through and talk about these, rationals, integers, natural wholes, irrationals, all of those are real. Okay, so I'm also going to say includes everything below. Okay, so real numbers, pretty much everything we deal with unless we're dealing with imaginary numbers. What about rational numbers? A number what? With a terminating decimal? Almost. I can almost go with that. It can be terminating decimal, or there's one other type of decimal it could be. Repeating decimal. Because generally speaking, it's any number that can be expressed as a fraction or ratio. Okay. Now you're not thinking of integers. I don't know. We'll see here in a moment. But so rational numbers, it is your terminating decimals because decimals that end can be written as a fraction. It is also your repeating decimals because repeating decimals can be written as a fraction. What it does not include are those big, long, random, messy decimals. We'll talk about those later. So I have written on mine any number that can be expressed as a fraction or ratio. You might hear the mathematical term might be ratio you hear, so and you get to keep writing that. Hello. Okie dokie. Bye. No, it has been found in the library. Okay, any number that can be expressed as a, I'm going to say fraction / ratio. Sorry, I'm already running into. Okay, so anything can be expressed as a fraction. If you want to write on your own personal notes, it's a terminating decimal, it's a repeating decimal. Okay. What are integers? And integers is a good word to use because you might see in a problem, you know, use integers. Write this with integers. Do you remember?
Is that like positive or negative numbers but no decimals?
Yeah. I can take that. Positive or negative numbers, but no decimals. I usually say whole numbers. Like, you know, we think when we hear the word whole, we think whole numbers, no decimals, right? Whole numbers that can be positive or negative. Now, In terms of what I write here, I don't really write a definition. I write more of an example set in that, okay, I'm going to do dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. Okay, in other words, there's your examples. It's 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. It's 0, and it's -1, -2, -3, -4, so on and so forth. So all those positive and negative whole numbers. Okay? Natural numbers.
Like 1, 2, 3, 4. Like Mrs. Rogers described them as like ones that you would know as a kid.
Yeah.
The ones you count with.
When you, yeah, and they're also called counting numbers. When you first learned to count, where did you start counting? You started with 1, yes? And that's where natural numbers, also known as the counting numbers, begin. Okay, it's what you learned in preschool, or probably before preschool, honestly. So I put counting numbers, and I'm just going to put 1, 2, 3, 4, dot, dot, dot. Okay, so natural numbers, think of, you know, what did you learn when you first started counting? Okay. What about whole numbers?
Positive numbers.
Okay.
Positive counting.
Okay, there we go. So it's your counting numbers again. They have to be positive. They're whole, so no decimals or fractions, but it also includes 0. So whole number is kind of what you learned at first, but when you started counting, your parents did not probably have you start with 0, did they? So 0, 1, 2, 3, 4, dot, dot, dot. And lastly, irrational numbers.
Repeating decimals.
What?
Or like numbers that don't have a terminal decimal.
Okay, decimals that do not terminate.
Yeah.
They go on forever, but they also do not repeat. Because repeating decimals, like 1/3, that's 0.33333333, right?
Mm-hmm.
So it's decimals that do not end and do not repeat. It's basically all of your numbers, all of your real numbers that are not rational numbers. All numbers are either rational or irrational. And so I have written down, how do I write? Decimals that do not terminate or repeat. What's an example of an irrational number? Okay, I heard pi. Is there anything else out there? It's not a common type of number that we deal with that's irrational. Huh?
Some square roots are.
Some square roots. Give me an irrational square root.
Is it square root of 7 one?
Okay, square root of 7. If it's not a perfect square, where I can just take the square root of it, it's irrational. When I put that in my calculator, it's going to be the type that fills up my calculator screen, isn't it? Big, long, ugly fills up the calculator screen. So those are a couple examples of irrational. Okay, words you've heard, right? It's just, you know, terminology we've got to remember. Types of decimals. We've talked about these, but let's make sure we understand. Terminating, I've used that word today. What's a terminating decimal? Okay, a decimal that ends. I'm just going to put ends right there. For example, make your brains work a little bit. 7/4. What do you know about 7/4?
It's an improper fraction.
Okay, it's improper fraction. How else can we write it?
4 3/4.
Okay, that's
5.
Yep, that's exactly how my brain follows. Is okay, 7/4. It's improper, so it's 1 and 3 left over, so 3/4. Oh, but we know 3/4, don't we? 1.75. So that's an example of a terminating decimal. It ends. What about a repeating decimal? don't know, how do we describe a repeating decimal?
Like 1/3 number.
Okay. Okay, just keeps repeating. Now, does it have to be just one number that repeats? No. For example, here's 1. 4 11ths. I picked one you guys don't necessarily know off the top of your head. I said it because it's not one I really know off the top of my head. You know what 4 11ths is as a decimal?
Is it that thing? Is it like 2 7?
No. That's probably 3 11ths. That's my
That's like
guess.
0.36 repeating.
Okay. So 0.36, 36, 36, so on and so forth, or 0.36 with a repeating bar above it. Okay. And how'd you figure that out if you didn't know? Calculator. What'd you do on your calculator? 4 divided by 11. I know, very basic question for pre-calc kids, but do we all need the reminder sometimes?
Yeah.
For the random person out there sitting there, how did they get that? Divide, guys, divide, right? 4 divided by 11. Okay, so we're good with this stuff, right? Okay, next thing we're going to talk about here is interval notation, which, by the way, we did figure out how to do the basics on our calculator, 4 divided by 11, right? So, interval notation. We talked last year a little bit about in Algebra 2, I believe, but the difference between inequalities and interval notation. So, if we talk about, first of all, a closed interval as opposed to an open interval, I'm going to give you 2 points. I'm just going to use A and B. But how do we express if we have the space between A and B is shaded or graphed or included? We express this as inequalities originally, right? So when we express this as inequalities, what are we looking at here? This space is, can I say greater than A and less than B? Does that sound familiar? Now, do I use equal to or not? What did I do? What kind of points do I have here? They're closed points. They're filled in points. So it's going to be equal to. We can also write this as A less than or equal to X less than or equal to B. Because when the shading's in between, you can also put your variable, which my variable in this case is X, and I can put that X in between. So that's saying that X is less than or equal to B. It's also saying that it's greater than or equal to A. Okay, so that's more what you've learned in your algebras. If I'm not mistaken, in Algebra 2 last year, we talked about interval notation. And with interval notation, on the ends, instead of using dots, we talk about parentheses and brackets. I don't know if we used them to graph. Okay. I don't know if we used them to graph necessarily, but instead of the closed points, we use brackets to indicate what's included in that interval. Instead of the open points, we'll use parentheses. So when I say brackets, I'm talking about basically square parentheses, right? And we write interval notation. We would write it as this interval starts at A, comma, and it ends at B. So the interval goes from A to B. And because they are closed points on each side, we use a bracket. And we'll do, let me make sure we'll do some examples of this on the back side of the notes, so that will hopefully help, if there's a little confusion out there. Now, what's the difference with open intervals? Instead of closed circles on the end, what do they have? Yeah, open circles, circles not filled in. And the idea now, when I'm expressing my inequality, it's not going to be equal to A and B. So as an inequality, you would write it as A less than X less than B. The difference with interval notation is instead of brackets, so the squared ones, we would use parentheses. And so in graphing, you would use the parentheses in place of the open circles. When writing the interval notation, my shading still starts at A, it still ends at B, but my endpoints are not included, so I use parentheses instead of brackets. Okay. Endpoints, what do I mean by endpoints? What are the endpoints I was using in those two examples? A and B. So just the points on the end, right? So A and B on those examples up above. Bounded intervals, what I was just doing up above were bounded intervals. They had endpoints, right? They're not going off to either end, okay? So any of these, any closed or open interval like this, where there's an endpoint on either side, we're not talking about going off to infinity. We'll talk about that here in a moment, but bounded intervals. So I just have written here any closed or open intervals such as above. So unbounded intervals. Well, bounded has two endpoints. Unbounded, it's not going to have two endpoints. Probably one endpoint, but it's only going to have one endpoint. And so in that case, if it's a situation where, how do I want to say this? Situation where like it's greater than or equal to something, then it's going to be going off to positive infinity. If it's less than or equal to something, it's going to be going off towards negative infinity. So, and again, I'll demonstrate this on the next page. We're going to use things, we're going off to positive infinity. We'll use our infinity symbol. Or, if we're going off to the left, we'll use the negative infinity symbol. For example, you know, up above I was giving you sample graphs that had A and B as endpoints, correct? Well, the idea now is now if we have sections, I usually I have two graphs there, so this is more of an or statement. But if we I give you endpoints here, where you have a shading at A, and then that's going off, right? As an inequality, I would probably say this is X less than or equal to A. As an inequality over here, I'd say this is X greater than or equal to B, correct? And I could even, oh my gosh. So if, how do I want to, as an inequality, this would be X greater than B. This would be X less than or equal to A. As interval notation, we think more in terms of reading left to right, and where do my intervals start and end. So with this interval notation here, we're looking at X less than or equal to A. Where does my shading start? Well, it's going off all the way to the left, yes? And what is off to the left if we keep going on and on and on? That's negative infinity. So this would be, you'd start with negative infinity, which always uses parentheses, comma. Now, if I follow this shading, where does this shading end? It ends at point A, and point A has a bracket. In place of the word or, interval notation often uses the U for union symbol. And then this interval over here, where does my shading start? My shading is beginning at B, and that's B with a parenthesis because it's not included, comma. Where does this interval end? Positive infinity, because it keeps going on and on and on, right? Positive infinity, and what I say about infinities, we always use parentheses. So we will practice that a little bit on the next page, and I'll walk you through a little bit more how it all relates. We did a little bit with interval notation last year, yes?
I don't think so. Because that looks like gibberish. Not gonna lie.
I did a little bit, but we didn't. We maybe did like a week of it.
Yeah. I don't know. You don't remember it?
No, that's
Okay, well, I can't. See, I can't speak for Tipton. I can't speak for Grad Point. I can't speak for what we've done at other places. But I'm trying to think in my classes. I thought I introduced it a little bit somewhere, but maybe I didn't. Okay, well, which is why I'm not just going to throw it at you and say you got it, right? I'll walk you through it. So, okay. Real quick, these examples. These will be easy. Determine if the following decimals repeat or terminate after finding the decimal form. 1/16. I don't know. Do you know anything about 1/16?
It terminated.
It terminates? How do you know it terminates?
It's a 1.
It's a what?
1/16. It's a
It terminates.
yeah. I know why. I can't explain. It just
You know
does.
why, but you can't explain. Okay.
It does. Okay.
I don't think
Doesn't matter if I can't. I'm right. So that's all that matters.
But you don't know what it is, so you're not that guy.
So this time you're
Close
right.
enough.
Is there whether your reasoning is right? Who knows? But okay, I'm going to agree it terminates. How do we know it terminates though?
1 divided by
I said
16.
so.
1 divided by 16 is,
0.061.
and that is a set number of decimal places on your calculator, right?
Yeah.
It terminates.
So, like my mind sees a number and it knows it terminates. I just don't understand
That's not how it
why
works.
I can't explain
Okay,
it.
well,
Nope.
it works for you this time. I don't know about next time. Okay, what about 55 over 27?
Repeat.
Repeat? Why? Because calculator says?
25 divided by
What is 55 divided by 27?
Yeah.
It'd be 2 and 1.7.
Okay. Calculator shows you 037, 037. So as we said, 2.037, repeating. So, okay, I'll agree. It repeats. And we're using our calculator, right? That's our crutch right now, which is fine. What about 1/17?
Terminating.
Terminating? Why?
1 divided by 17.
And what is 1 divided by 17?
0.058823529.
Was I right? Can it?
So it's pretty long.
You got
Do we know where it goes after that? I mean, here's the thing. My basic, not high mathematical thinking here, but it terminates if you can see the set number of decimal places on the calculator screen. When it fills the calculator screen, it usually keeps going, right? Does that appear to fill your calculator screen? I mean, granted, these are new calculators to you, so you don't exactly know what fills your calculator screen is, but it does. It's filling your calculator screen.
Sure.
So it keeps going.
Keeps going, but it never repeats. There's no 0.37. It's just a bunch of numbers.
There's no end.
There's no end. What
Okay.
is it?
It's
So-
irrational.
Here's the deal. What if I tell you it does repeat? Is it possible that that will repeat eventually?
Eventually.
Yeah, eventually.
Yeah. Now, how could we, we're not going to, so don't freak out on me, how could we show repeating here if we really wanted to work hard?
Long division. Yeah.
Long division.
So double division is so long.
Okay. Now, as I said, don't freak out on me. Are we going to do that today?
I
No.
feel like we should just do it now. You talked about
Okay. So, 1/17 was that big long thing Kylie read. Okay. It keeps going though, because if you look at your calculator screen, that's the extent of your calculator screen. That's a filling your calculator screen type 1. If you try and do something, I'm curious. You still have 55? Oh, you don't have 527, so I'm just
I do. Oh wait, no, he's just kidding.
But okay, so I was just arrowing up. So I just used the arrow up, and even though Sophia cleared her calculator, I can still arrow up to the last things I enter. And so I was just arrowing up, and if you look and you compare like the 1/17 and the 55/27ths, I don't know what, okay, yeah. They're about the same length. Yeah, they're about the same length, aren't they?
Mhm.
On the calculator screen. So that's the filling your calculator screen. So this does repeat. And it's one of those things, unless you really want to, you just need to take my word for it. And I'm going to say it repeats via long division. Okay.
Can you show us example on division problem?
I could, but do we really want to take our time there?
No.
I'm not going to. Don't worry, we'll talk long division at some point this year, I'm sure.
Yay.
Did we do it on the PSAT? I think like all of us, someone had told us,
Yeah,
oh,
there
there's
was
long
on the
division
PSAT.
PSAT, and then we all like went through
I
it.
guess
Maybe
they
you weren't
didn't.
there. No, I was. I made Mario reteach me.
I forget long division.
I usually teach, what class is it that I teach? I think Algebra 2, we reviewed long division before we did long division of polynomials. So, I'm pretty sure, I'm more positive about teaching that one, so. Okay, and so this goes back to our intervals we were talking about, the interval notation. And a couple of, we're gonna put it talking about in words. So describing the graph. And we're going to talk about, describe and graph. So we're going to describe in words, we're going to graph it, but I'm also going to talk about, okay, what is this in interval notation? So I can get you guys more used to what was termed as gibberish earlier. Okay. Well,
That's just what made the most sense.
I get it. Okay, so A, I'm not reading the problem to you. What does A say?
X. This is less than 3.
Less than 3. And I didn't read it to you because at this point in your life, should you know which sign that is? Yes. My elementary trick is it's the less than sign because it's the one that kind of looks like an L.
Oh, that's much
I was
easier
taught
than
like
the alligator.
Yeah.
Well, I can't. Okay, here's the deal. I can't use the alligator
And
anymore.
then you draw the
And why can't I use the alligator? Because you're going to say 3 is bigger because it's eating the 3, but yet we don't know what X is, do we? So I stray away from the alligator. I go more with, if I write an L, that just looks like a sloppy L, doesn't it?
Yeah.
Like my L could really easily turn into a less than symbol.
So that is so much easier.
And
So-
now we
How come
decided
they
to
never
tell
told
us.
us that?
I was just
I mean,
wanted to
Graham-
change like clapping my hands because they said alligator.
That was
Okay.
Yeah, alligator.
So first of all, get out of the way that it is X less than 3. So if I put that in words, what does X less than 3 mean? What does it
X?
include?
It includes 2, 1, 0, and all the numbers below that.
all of the negative numbers.
I don't know
Okay.
why I counted
Any number
like
below
that.
And technically,
Any number
besides
below 3.
2 and 1 and 0,
It
are
could
there
be
also some
like
decimals and fractions in there?
2.99 repeating.
Okay. So for words, I'm going to write real numbers less than 3. Now, I probably said it last year in Algebra 2, but you guys realize that's not a hashtag, right? Long before it was ever the hashtag, it's a number sign, also known as the pound sign. But, so, just say. Okay.
I had no clue that was a pound sign until I was doing something at work, and I'm like, oh, that's so many pounds of goat feed, and I was like, what?
LB?
Okay. Now, how do I graph this?
Octosaur.
What number is going to have to be on this number line to graph it?
3.
Okay. Minimum. There's got to be a 3 on there, doesn't it?
Yeah.
My teaching style, I always say put a couple numbers on either side. Some teachers will say you have to have 0 on there. I don't necessarily say you have to have 0 on there, but you need a few other numbers, right? I prefer not just that you say 3. So I'm going to say 1, 2, 3, 4, 5. Put whatever numbers you want in there. How do I express this graph on my number line?
Circle above 3.
It's like the open dot.
Okay. Circle, open dot,
And then
Except I'm not going to do that. And then we're going to shade left, yes?
Yeah.
Now, instead of circle or open dot, what did I mention on the front side? Parentheses.
Yeah.
So here's the deal. My shading is going to the left of 3, yes, however you shade. And then instead of an open dot, I'm going to put a parenthesis. Because my shading is going left, my parenthesis is opening to the left. Does that make sense? If my shading was going to the right, my parenthesis would open to the right. So, we're talking interval notation. Interval notation is an important concept to grasp. With that in mind, when you guys are doing this stuff in homework, instead of using the circles and the dots, I want the parentheses and the brackets, okay? And so work to make that transition. Now, it doesn't ask me to write interval notation, but I kind of feel like we could use as much interval notation practice as we get while we try and learn it. So as we write this in interval notation, here's what I do. Where does my shading begin? My shading begins at the left arrow, which the left arrow represents negative infinity, yes? So I'm going to put it right up here. Negative infinity, comma. Where does my shading end? 3. So in interval notation, this is negative infinity to 3. Infinities, always use, is it parentheses or brackets? Parentheses. And what about the 3? Does it need a parenthesis or a bracket? It was an less than, an open circle, so it's a parenthesis. So there's an example of interval notation. When you ask to write something in interval notation, that's what I'm looking for. And we do a lot with that in pre-cal, okay? Questions on A before I move to B? Okay, so B. -1 less than x less than or equal to 4. Well, let's either talk about the graph or let's talk about words. I don't care which we talk about first, to be honest.
Graph.
Okay, what about the graph? How is this graphed? Well, as I said, we can go back and we can talk words instead.
Let's start with words.
I mean, the graph, even if you don't know how to graph it, you know there's got to be a -1 on there, right?
4. Yes.
And there's got to be 4. I mean, even if you're not there on what we're graphing, if that has not processed, you know those numbers have to be on the number line. Okay? What is this? If we just look at this right here, and if I cover the BenQ, I'm going to write on it, but if we just look at the x and that symbol and 4, what does that say? X is less than or equal to 4. So where is that on a graph? X is less than or equal to 4. That is where? To the left of 4, yes? Okay. What about this piece? -1, a less than symbol in x, which my recommendation is always, if you're looking at that and you're saying -1 less than x, what do I always encourage you to do? Those of you who have had me before, I always say flip it, because then if we flip it, that means you flip the sign, x is greater than -1. Where are numbers that are x greater than -1?
Going to the right.
We're going to the right, yes? So what's going to be shaded here?
Everything in between.
Yeah, everything in between -1 and 4. Okay? When you have that x fall in between two numbers with less than symbols there, it's everything in between -1 and 4. Now, at -1, not open or close circle, parenthesis or bracket.
Wait.
At -1.
Oh, right. Parentheses.
At -1, it's a parenthesis. It's not equal to. So we use parenthesis. At 4, it is equal to. So there's a bracket. So what did we just shade? We just shaded all real numbers where? Yeah, all real numbers between -1 and 4. Now, I will add on, I'm going to tack on a little bit at the end here. So, all real numbers between -1 and 4. Now, if I'm officially going to put this in words, I've got to talk about the endpoints. Does it include -1 or does it exclude -1? Does it include 4 or does it exclude 4?
Excludes -1, includes.
Okay, so -1 it's not equal to, so it excludes -1. 4 there is an equal to sign, so it includes 4. Does that make sense there? So I'm going to say excluding -1 and including 4. That's your words there. Now, if we want to talk interval notation, your interval notation is basically right here, guys. Take it off the graph and you've got your interval notation. Because where did my shading start? -1. Where does my shading end? 4. Parenthesis or bracket at -1. Parenthesis, it wasn't equal to. Parenthesis or bracket at 4. Bracket at 4 because it was equal to. So that really just mimics it, doesn't it? Okay. Let's go ahead and look at A. Write an interval of real numbers using an inequality and draw the graph of the following. So this time they're asking us to put in interval notation and draw. So technically never even ask. Wait, no. Let me read. I can't read my own directions here. Write an interval of real numbers using an inequality and draw the graph. Okay. So inequality and graph is officially what we need to be doing. As I said, I'll throw in interval notation just for practice. The real numbers between -4 and -0.5. Excuse me, -5/10 if I want to be official. So what's that look either as an inequality or as a graph? I'll take either or first. I'm not picky. I was writing the graph out in the meantime. Because again, even if you don't know what you're graphing, whoops. I know I'm going to need -4 and -5/10 on my graph, right? You know. Remember when you're in negatives, you're counting the other way, yes? So where are the real numbers between -4 and -5/10? They're where? They're in between, yes? It says the real numbers between. Now, important question. Parentheses or brackets? Does it say they're included? No, it just says between those. So what should we assume? I'm going to go with parentheses because it's not indicating that those numbers are those endpoints are included. Now, as an inequality, when I ask for inequality, I'm talking throw me an X and throw me some less than greater than signs. So, we had this before, didn't we? Wasn't our last example like this? Our last example was all real numbers between two numbers. How is that written as an inequality? X is between -4 and -5/10. Where's my shading going in relation to -5/10? It is less than. Officially, where's my shading going in relation to -4? It's greater than, but my X is flip-flopped and on the right, so we say another less than symbol. So -4 less than X, less than or equal to -5/10. If you want to do an interval notation, it's right there, guys. Interval notation, my interval starts at -4. My shaded interval ends at -5/10. And both pieces have parentheses. And remind me tomorrow if I forget. We're going to stop there. This bell should be ringing very shortly. Okay, homework. Here's what I'm going to say about homework. Can you start homework tonight? Yes. Is it due tomorrow? No, it's not due tomorrow because I have not finished these notes. So if you want to go ahead and start looking at it, you can. Otherwise, I'll finish notes tomorrow, and my guess is we'll probably have a little bit of work time because it won't take me the whole time to finish the notes, and go from there. Okay?